So the theme now, and this will be the last thing that we learn before our next quiz, and honestly, before our district assessment, there's going to be actually a lot of points coming up in the next week or so, week and a half, and that's a quiz. That'll be worth a lot, and then a district assessment that'll be worth a lot. So grades can change a lot in like the next 9 or 10 days. So what we're going to be given is a function. Just more with the rational root theorem. That's it. So we've really entered now, bless you, we really entered the top level. Like if we were climbing Everest now, we're kind of making the final summit here. This is it. This is all you get. How many answers do we expect? 4. So what's going to change today is I'm going to ask you to find 2 on your own, and then the other 2 are never up for searching and hunting. It's just robotic quadratic, either factor the rest or quadratic formula or whatever strategy we decide to use. So the key here is to start, we are on our own. I know what they are because I wrote these, and so they're sitting in front of me, but you sitting here, you have no idea what the answers are. And I will give you 2 rational ones, meaning that they don't have roots in them or eyes or anything, right? So like you might get answers like 1/2, 5, 3, -2/3, stuff like that. And those are the ones that we have to track down on our own. So there will always, if there's 4, I'm going to give you the opportunity to find 2 good ones. And then you get it down to second degree, finish from there. So if it's a 4th degree, expect to be able to find 2 using synthetic division. Anyone notice anything that we could do on this one? What do you mean by that? Yeah, and this won't always be possible. Sometimes when I write them, it happens. Sometimes they don't. But this one, if you catch it, it's going to save you actually quite a bit of work in the end because you can GCF it before you bust out the rational root theorem. So we could actually take this polynomial and dip it down. We could take all the numbers and divide them by 2, which is going to now turn this into 4x to the 4th. Keep an eye out for this because it will help you when the opportunity presents itself. Plus 11x cubed minus 28x squared minus 28x plus 16, right? So this is actually now the function that we want to work with, and no harm, no foul there. We're good. So now we're going to bust out the rational root theorem. So we learned this yesterday. What do we start with on this?
The first and then the last number.
Right. So the key is understanding that everything you need right now is in the red circle and the yellow circle. Like everything in between at this point is irrelevant to us. The rational root theorem says that if there are rational roots, which I told you there will be 2, they're going to come from some rational value built from the red and yellow. So we take the factors of the red and we put them on top. What are the factors of 16? 1, 2, 4, 8, and 16. Okay, and then what are the factors of 4? So at this point in time, our job is to write out a comprehensive list of all possible rational zeros. And it's just really a matter of building fractions. Every combination of the top and the bottom has to be considered. I would always go through and consider the bottom one first, and that enables me to find positive -1/1, positive -2/1, positive -4/1, positive -8/1, and positive -16/1. So we should always start our list of candidates like that. Okay, with 1 now out of the picture, I'm going to go ahead and erase the 1 because we've used it. Now we're on to the 2. And now we're going to build all the possible fractions that have 2 as their bottoms. What's the first one? Positive -1/2, right? That's a new one, so we need to acknowledge it. But now, just like yesterday, you're going to see some serious redundancy repetition stuff going on here because the next one would be 2/2, which is already done. 4/2, already done. 8/2, already done. 16/2, already done. So as we saw yesterday, when there's a lot of even numbers, you're going to see a lot of repetition, which is a huge time saver. So now I can eliminate 2 from my list. used up. You can cross them out or not. I don't care. Don't scribble and vandalize too much because I want to be able to read it at some point. Just cross it out, maybe something like that. And then we got to build all the possible fractions that have 4 as their bottoms. And so the first one is 1 over 4. So we have a positive negative 1/4. And I think we're about to see some more repetition. The next one would be 2 over 4, which is a half, already done. The next one is 4 over 4, which is 1, already done. 8 over 4, already done. 16 over 4, 4. So even though there's a lot of red and yellow numbers, or there were before I killed them, there's really not that many potential candidates because there's a lot of redundancy. So this is where we dig in. And so step one is build your workspace. And the workspace, remember, is built by setting it up with these 1, 2, 3, 4, 5 numbers. So we're going to set it up with a 4 and an 11 and a negative 28 and a negative 28 and a positive 16. Build your synthetic division sign. And then we start testing. And you can, by the way, if you wanted to, like, I know I said yesterday, you can do part of this in pen. I mean, or not, I don't care. But I like copying down the 4 is something that you could also do in ink because it's going to be a non-negotiable. So we begin. And this is the part where it's up to you, right? So what would you like to try first? -4. It's pretty random, but I like it. So let's give -4 a test drive. All right. So now the algorithm kicks in, and as I said, the quicker and better you are at this, the less frustrated you'll get because you're not going to be burdened by basics. So we drop the 4, we have -16, we add, we get -5, we multiply, we get 20, we add, we get -8, we multiply, we get 32, we add, we get 4, we multiply, we get -16. Well done, Katie. Thank you. So, I mean, that could have taken 5 minutes to get there, or in this case, it took us 10 seconds because it looks like Katie had already worked ahead and figured it out. So nice work. So what separates today's lesson from yesterday is that that's not the be all end all. Like yesterday, we found 1, patted ourselves on the back, and we already were down to quadratic fill. Whereas here, we're not. We're still in cubic fill. And maybe if with any luck, you could, I mean, again, it is luck. Maybe you could look at those 4 numbers and say, ooh, maybe I could set it up as a grouping problem. But again, with practice and experience, you look at that and realize that ain't happening, right? I could draw the little wall down the middle. It ain't going to GCF itself out by grouping. So the hunt continues. So what we do now is we draw another synthetic division sign. Remember, we piggyback down off of this one. We've seen this before. We've never done it in the context of where we were the ones hunting. Like we did it when I gave you 2 freebies, but not where we were still hunting. And so we go again.
The same number.
You can. You can use -4 again. It's not going to work this time, I can tell you from having written this problem, but there might be instances when the same number can have multiplicity. It's an excellent question, Kane. So you can sometimes see that, wow, I just used the same number. I hit it twice and it produced a 0 both times. Sure. Yeah, I mean, we can try any numbers that you want. So if we try +1/2 and then we kick in the algorithm, half of 4 is 2, -5 plus 2 is -3. And this is the part where I told you this before, but we've never really seen it in the wild. But here it is. This is where you might want to jump ship because, it's probably not the best advice, but I find that almost always, well, like, what's half of -3? -3/2, right? And so now I've got myself in a predicament where now I'm working with fractions, and watch how ugly this gets. This is now -16/2 minus 3/2, which is -19/2, and half of that is -19/4. You could really feel it go off the rails right about there. I hope you should feel that. And when it started to go off the rails, that's a pretty good sign that we just turn around and walk the other way and try something else. Okay. You'll know when these are flowing right, when they're working right, and all the numbers kind of are feeling good, you'll know. And when they're feeling bad, you'll know. So, what else would you like to try? Positive two? Sure. And these are all candidates off of our list. And so we're trying good things here. And when they fail, you just check them off your list. If they don't work, that's okay. It's one less thing you got to try later. So if we try positive two, we drop the four, multiply eight, three. This is feeling good. The numbers are staying sweet. Like if you early on get like 126, then you're like, I think that's good, right? But we're staying in the pocket. We're kind of hovering around zero, going back and forth. Two times three is six, negative eight plus six is negative two, two times negative two is negative four, and we did it. And by we, I mean Katie did it. Thank you. So that's what's new is that now you're going to be on a hunt for two rational zeros. And again, going back to Kane's question, the same number could work more than once. So if you find a winner, try it again just to be safe. Because it would be kind of funny in a mean way if you had it and then came full circle back and tried it again. And you're like, I could have just done that the first time. So do keep an eye out for that. But in this case, we're down to, I think, a territory that God, I hope we're familiar with. This is 4x squared plus 3x minus 2. And would you like to finish this? It's up to you. Keep going. Okay, let's finish. Make it official. This is just, I mean, quadratic formula for like the 48th time, right? So A is 4, B is 3, C is negative 2, and we're off. I mean, I looked at it, you looked at it, we can't factor it, right? And that ain't going to work. So we know we're going down the right pathway. What's the first thing going to be?
Square root of 9 - 4.
Thank you for that. Perfect. And then all divided by 8. Thank you. And then in the two blanks that I made, go A and C, which are in this case 4 and negative 2. What is the inside of the square root actually going to say? You guys are really good at this. 9 plus 32, which is 41. And that's such good news for us. I've said things like this in the past, but they never really make sense until you're ready for it to make sense. And you should know that that's great news. Dead roots are the best thing that can happen because it means we're done, right? There's something satisfying about like the square root of 40 and you can break it down and do the Dorito. But at the end of the day, it gets boring and it's just more work. And so the answers for this problem are going to be the things that Katie found for us. The first one that you found was negative 4. So now we're going to say x equals negative 4, comma. The other one she found for us was positive 2. Those are the two that you're searching out. And then the others are not about a search. They're about just grinding it out at the end. So our final answer is x equals negative 3 plus or minus the square root of 41 over 8. And we were expecting 4 answers, and there they are. 1, 2, 3, 4. Done. I would like to do one more. I'm calling an audible right now and saying we don't need to do 3 of these because it's going to gobble up a lot of your class time. But I want you to see that they can even be a little bit more uncomfortable than that. And if you don't know what I mean by that, well, you will. Let me ask you this as sort of a hint, 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 wink, wink. What was nice about the ones that Katie found for us? They're whole numbers, right? Integers technically, but they're not fractions. So that will not always be the case. Hint, hint, wink, wink. So our last one, and if you want one more, I have it. I could sit and work with you. When I cut you loose for work time, you could come up and we can do a third one together if you'd like. So this one's going to be 21 x to the 4th plus 20 x to the 3rd minus 40 x squared minus 8 x minus 32. What sucks about this is not a GCF, right? The 21 really gets in there and messes this whole thing up. All these other 4 numbers are like, hey, we're all divisible by 4. And then 21's like, sorry, suckers. I'm trash. He's divisible by 3 and 7, but none of the other guys are. So it's like, well, I guess we get what we get. So it's time to just hop right into the rational root theorem. So what are the factors of 32? Okay, good. Yep, I agree. Okay. One, two, four. Yeah. Because 32 is a power of two, its factors are kind of interesting. Feels like it ought to have more than six, but it's just got those. And then on the front end, what are the factors of 21? So you can see this one is going to, and you'll also see why there's not a lot of problems on this next assignment. Giving you 10 of these would make me a very, it's unreasonable is what it would be. And I'm not about that. So three or four of these, and I think we're good to go. These take time. They're annoying. You find them to be annoying and difficult. They are because there's a lot of trial and error that we have to go through. And if you're not methodical about this first step, you're hosed. So we're going to start with the number one, and we're going to take all of our whole number potentials. So we have a positive negative one, positive negative two, positive negative four, positive negative eight, positive negative 16, and positive negative 32. But this you see is going to be really ugly because of how many odds and evens are at play here. I wouldn't be surprised if we don't see a lick of redundancy here, like none. So there were six there. We're looking at potentially like 24/48 possible candidates here. This is where it's really good when you work together tomorrow to be productive and to divvy up the task. You know, if you have four people in a group working together, it's smart to say, you take these four, I'll take these four. And then it can take 5 minutes instead of 20 minutes. So, and now we begin the rest of the process. So now we're on to the three, and we take everyone and put them over three. So we have positive negative one third, positive. And I probably won't give you any of this obnoxious like on a test, just for the record. So positive negative two thirds, positive negative four thirds, positive negative eight thirds, positive negative 16 thirds, positive negative 32 thirds. One thing you do know is that I'm probably not going to give you negative 16 thirds, right? Like I'm not going to do that to you. So we can sort of whittle down. I'm not like a third year college professor. Like I'm not going to torment you. So we can stay in the pocket. Like four thirds isn't out of bounds, but I feel like 16 thirds is. So we, even though we're getting some that are a little bit intimidating, um, I'm not going to make you, I'm not going to make you find those. So whatever that's worth. Okay, so we're done with three, and now we're on to the seven. So we have positive negative one seventh, positive negative two sevenths, positive negative four sevenths, positive negative eight sevenths, and positive negative 16 sevenths, and then positive negative 32 sevenths. And now we're almost done because now we've used up the seven, and now it's on to the 21. So we've got six more that we need to write down. So positive negative one over 21. And again, that's not going to be one of them. Okay. I'm gonna keep the ones I want you to find in the sweet zone. Like that's a sweet zone, sweet zone, sweet zone. Now, eight thirds is a backup plan. Sweet zone is, these kind of more reasonable ones like this, but don't start with 32 sevenths for goodness sake. Yeah, that's a bad idea. But anyways, got to finish this off. So positive negative 2/21, positive negative 4/21, positive negative 8/21, positive negative 16/21, and then positive negative 32/21. It's a lot. As advertised, that is exactly 24 pairs of positives and negatives for a total of 48 candidates, a lot of which are not really in play. Okay. If this were like a third year mathematics course at UW, I might make you try to find 32 sevenths, but I'm not going to. So, having said that, let the games begin, right? So we're going to start by building our template. So I'm going to slide this up just a little bit, and then we're going to make our numbers and get the workspace set. So we have 21, 20, negative 40, negative 8, negative 32. I'm going to scroll up even a little bit more now. I no longer need the original problem. I just need my list of candidates at this point. And I wanted to do one more little touch before I say workspace is set. There, drop the 21. We're good to go. Um, you see that not all problems are created equal, right? The last one was pretty tame and simple. This one is not. This one's kind of nasty. So you don't find anything yet? Okay, good. And this is where working as a team is so critically important. And so I know that we're not talking to each other right now, but as a team, again, you would talk a lot and you would divvy up the tasks. But Steve sounded pretty confident about -2. Let's give it a spin. So -2, that's going to make -42 add, -22 add, or multiply 44, add 4, -8, that makes -16, that makes +32. Thank you, Steve. One down, one to go. So again, you could try -2 again at this point in time. That goes back to what Kane said. It could work twice. It won't this time, so I'll save you the time. Anyone else? I can tell you this, that there will only be one question like this on a quiz, and it won't even be this hard. This one, I will admit, kind of got away from me a little bit. I got a little math happy when I wrote this one. So I will tell you that the other one is a fraction. So you knew that if you were listening. I was dropping some serious hints. +4/3. And I would say again that Stephen didn't say that with the tone of someone who was wondering. It sounded to me like a young man that has worked this out and is pretty sure. So do your hook algorithm. 21 divided by 3 is 7 times 4 is 28. -2, 22 plus 28 is +6. 6 divided by 3 is 2 times 4 is 8. 12 divided by 3 is 4 times 4 is 16. And thank you, Mr. Archer. There it is. And we made it. So that's really what today's lesson is about, is you get to track down 2 rational zeros instead of just 1. Okay. But again, you see from that example, like we had a whole bunch of stuff in this list that never got touched. As I said, and I was pretty clear about it, I'm not going to give you things like this. I feel like, I mean, and there's even more maybe that I could cross out, but I mean, look at, I just eliminated 1, 2, 3, 4, 5, 6, 7, 8, 9, 18 of the 48. In reality, you still have to make that big comprehensive list. But the fact of the matter is, like, some of the obnoxious ones, don't go there. You're not going to need to. Look for the sweet ones: a half, 2/3, 3/4, 4/3, 3/2, stuff like that. And again, let's make it official. Let's finish the problem. But to this point, our list of answers contains 2 numbers. We just need to find the other 2. So these 3 numbers down here are the coefficients of a quadratic. What do you think? Okay, good. Yeah, let's divide them all by 3. I agree with that. So if we divide them all by 3, they knock down to 7 and 2 and 4. And now we just have ourselves a real simple little quadratic formula problem. Not factorable again. It ain't happening. So A is 7, B is 2, and C is 4. And we're off. What's nice about some people find the quadratic formula to be like cathartic and soothing. I mean, others they hate it, but I find it to be relaxing because I don't have to think. I don't have to try to problem solve. I'm just doing a process that I've done 10,000 times before, and it's relaxing. There's no get it or don't get it. You're just putting numbers in place of letters and doing basic math. So here we go. X equals what?
2 plus or minus the square root of 4 minus 4 of 1.
Thanks. Nice. So this one's going to have some i's in it, right? You can tell because the minus is never going to have a chance to switch to plus. And we're doing 4 minus a buttload. And last I checked, 4 minus a buttload is negative, right? So you got to be able to do the math in the back. These 3 numbers in the back in the yellow oval, they make 16 times 7, which is 112, I believe. And 4 minus 112 is -108. So you're going to get minus or negative 108 inside the square root. Use your calculator for that kind of garbage, right? You either just type in 4 minus number, 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 or 4 plus number, 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 having considered the sign before you even start. So we go off to the side now and we break down the square root of 108. Notice I did not say negative 108. I'm not worried about it. It's a little thing. Stick an I in there. It's no big deal. Anyone find 108 yet? It's a pretty rad combo for 108. I will say that 9 and 12 make 108, which is pretty cool, but 12 is not dead, so don't use 9 and 12. Nine's rad because it's on the red list, but 12 is not good because it's still got meat on the bone, so don't go there. Sometimes remember what I said is to divide by baby trash is a good idea. And what I mean by baby trash, remember, is numbers that I don't give a crap about. Like no one cares about 2 and 3. 4 and 27 is pretty rad, but again, 27 still has meat on the bone. So if you can do math in your head really well, try dividing by numbers that are garbage. Dividing by 2, you think, why would I do that? 2's not on the red list. But if you divide by 2, you get 54. And you go, okay, that was a waste of time. Try dividing by 3. 3 is another number that we give zero craps about. But 36 is not. And so I can discover, if I divide by baby trash 3, I can discover and unearth this beautiful number named 36. 36 times 3 makes 108, and the square root of 36 is 6. So what we're going to have now in the next step of the quadratic formula is we're going to have negative 2 plus or minus 6i root 3 all over 14. Any questions about that? Okay. And the Dorito is in play. Whenever someone breaks out of jail, you have to consider the Dorito. Whenever a number falls into this place right here, Dorito is in play. And this is a productive Dorito. Sometimes with the Dorito, you get like 4, 5, and 6, and you're like, well, I can't do anything with that. But in this case, they're all even. And it's like the 100th time we've seen this. So let's make our list. So let's begin. What was the first number that we found, or that Stephen, more to the point, found? So negative 2 is on the list. What was the other one that we found? Okay, so we always want to put those down. And now the conclusion of the list is going to be the ones that we found from the quadratic. So in this case, we're going to say x equals what? How do I express this up here? Not yet, buddy. I need a number in the first. There's always needs to be a number in that. Yeah, that's the only place where ones are really important. Okay, so negative 1 plus or minus 3 root 3 over 7. Yep, because we're dividing everything by 2. So it was a little longer than I meant. I said 20 minutes. It was like 25 or 28 or something. So apologies, but you can't shortcut things like this. So we could have saved time if we didn't finish, but I know that there's something to be said for just having a done problem in our notes. So listen, let me say this before I shut this off. The rest of today is time for you to work on assignment number 16. All day tomorrow is going to be work time for assignment 16, 17, and hopefully a practice quiz. So that's it. Good. Okay, cool.